All right, what about the smile here? Where can I draw a line of symmetry where when I flip it over, it'll match exactly up? You're going to start off side? Right between the eyes. Yep. Flip that over. Anywhere else? No. What about the sideways heart? Sideways heart. That's what I was thinking. Okay. We'll go back to them. What do you think? Can I get one between 1 and 100 that's in here without even changing it? What do we think? I'm not going to do this too much longer. 20. There we go, right here. Is it possible to have more than one line of symmetry? You're darn right. Multiple lines of symmetry coming up here. Multiple lines. Almost. All right, I'm done. Let's get back to work. 5. The diagonals, absolutely. All right. Before we get on to this next one, I will let you know that this is an equilateral triangle because that helps, because if it was scalene, there would be no lines of symmetry. So a little bit tougher here. Let's start thinking. Where could I put my lines of symmetry here if it's equilateral? Saad? Each vertex, yeah, basically the what of each vertex here? The what? Angle bisectors, yeah. Okay, that would all cut it in half. All right, now I'm going to turn it over to you. Other than the letter O, let's start naming some letters that have line symmetry. Oh boy. Letters that have line symmetry other than O. Madeline, start us off. Uppercase A. Look at, we're even getting detailed. It's got to be uppercase. Yes, uppercase A here. Can have any type of line of symmetry. Here we go, Saad. Uppercase B. Yep, horizontal. Don't start getting on me. Oh, I believe your upper hump is a little bit smaller than the lower one. Get out of my face. Get a life. Okay. Next up, James. W. Got the dubs. Yep. We're going to keep this train going. There's 26 of them, and I only have 3 up here. And you needed help from that. Andrew. A V. All right. Maybe one more here, Madeline. What is it? X. Yes. Okay, now I'm going to challenge you even more, honors kids. Words that have line symmetry. Can be horizontal, vertical. I can write them up and down. I can write them left to right. Rose? Boy, how would that have? Because the B and O would have horizontal, right? See what I mean? Your Y does, but it's got different line symmetry than the B and the O. So we're getting on the right track here. Nate. How does this are we picking up? You guys just can't put letters together that have it. Like they all have to have horizontal, they all have to have vertical. How do you want me to write that word bad? Where it's got. Are we good? Bad's not going to cut it? Do we see why? Madeline, help us. Okay. That's it. Let me know when you're on my level. Right there. Checkbook. Checkmate. All right. Yep, right there. Let me know when you come a little stronger. Okay, let me know when you come a little stronger, ladies and gentlemen. You're in the big leagues now. All right, you're in the big leagues. Checkbook. Anything else? Let me know. All right, you guys can work on that one. Line symmetry, that's what you guys are used to. Now I'm going to show you two new types of symmetry that you probably are not accustomed to at all. First one is point symmetry. Point symmetry, where if I turn it 180 degrees, it's the same figure. 180 degrees, basically turn that thing upside down and it's the same figure. All right, so take a look at my square. This is a square. Turn that, everyone, if you want to turn your paper upside down, do I get that same square back? Yes, so we say this has point symmetry. What about this triangle here? It doesn't matter if it's equilateral or not. Turn it upside down. Is it the same triangle I started with? No, so this does not have point symmetry. It has to be, turn it 180 degrees, rotate it 180 degrees, and you get the same figure as the original. Are we okay on why the triangle is not working? And then what about the circle? Obviously, yes. All right. All right, let me open it up to you guys now. Letters that have point symmetry, except for O. Letters that have point symmetry. I rotate it 180 degrees and it's the same letter. X has point symmetry. Got it, Nate? But you're killing me with the, hey, turn that upside down. Is it the same D? I believe it's going that way if I turned it upside down. Right? I don't think D's going to cut it. What's up, Andrew? You tell me. Draw a Z, rotate your paper. Is it the same Z? Darn right it is. All right, what do you got, Evan? I. Yep. Stacy. S. Yep. That's Z and S are ones that have point symmetry but do not have line symmetry. Okay, those are two letters that have point but not line symmetry. Frank? Uppercase N. James? H. What do I know about H, I, and X? They have both point and line. Madeline, one more? Okay. I'll put it in there under protest. Yes. All right. A little point symmetry there for everybody. No swims on Monday. I know, it's pretty good. It's pretty good. I'm killing it today. Questions about point symmetry? Turn it upside down, it's the same thing as you started with. All right, last type of symmetry, and we have already talked about this type when we did the honors rotation day, but rotational symmetry. Can you turn a figure less than 180 degrees and get that same figure back? So 180 degrees or less, can you get that same figure back? Let's start with this hexagon, which I will tell you is regular. This is a regular hexagon. Okay, regular hexagon. Can I turn this, rotate this hexagon 180 degrees or less and get the same hexagon back? Can I do it? If you remember from our honors rotation, the answer is darn right I can. Do you remember how we found the degree of rotation from vertex to vertex? Anybody remember how we found that degree of rotation? Because if I rotate this figure from here to here, it's going to be the same hexagon. Or from here to here, it's the same hexagon. Evan, you remember? Well, we did 360 because when I go all the way around, it's 360. And yes, it ends up being the number of sides, but it's also the number of turns before I get all the way around again. So divided by 6, what's the minimum number of degrees I could rotate that? 60 degrees. So every time I rotate 60 degrees, I'll get that same hexagon back. Okay? Everyone all right? What about this? I believe we did one already, but equilateral triangle. It has rotational symmetry. What is that degree measure less than 180 that I can rotate it? And how are we finding it out? Start hearing from some of the crowd here. 2. To divide 360 by 3, which is the number of turns I can do. And I end up with 120. And again, this is just the minimum amount of degrees. What other degree measures could I rotate other than 60 over on the hexagon? 120, 180, any multiple of 60. What about this one? Not equilateral. Can I turn this? You can even turn your paper now. Can I turn it anywhere smaller than 180 and get that same triangle looking figure back? Anybody doing it? Me neither. So this does not have rotational symmetry. So no rotational symmetry. And what about this figure? Can you guys rotate it 180 or less and get that figure back? Anybody? Can you rotate it 180 degrees or less and get that same figure back? $12? What do we think? 12? Hi, Frank. I can rotate it 180, and that's good enough. It's 180 or less to have rotational symmetry. All right, so it's going to be 360 divided by 2, right? Because you can turn it 2 times. And yes, 180 degrees. So this does have rotational symmetry. It's got to be 180 or less. Questions? Whoa, we're not ready to go on yet. Questions? All right, I want to start giving a name now, if it has rotational symmetry, to this 60 degrees and the number of times I can rotate it. To this 120 degrees and the number of times I can rotate it from 0 to 360. We're going to give a name to each of those, and here they are. The number of times I can rotate it, that's the order now. Order is the number of times you can rotate it from 0 to 360. So going back, I'm going to regret this. Going back, my order would have been 6, 3, 2. The number of times I can rotate it, that's my order. And the number of degrees I can rotate it, that's the magnitude. All right, so the order is the number of times I can rotate it from 0 to 360 and get the figure back. Magnitude is the degree measure. All right. So for part A, state if it has rotational symmetry. If it does, what's the magnitude and the order? So we've already done part A. This is a regular hexagon. So instead of saying rotating it 6 times, I'm going to say the order is 6. Order is 6. If the order is 6, magnitude, the smallest degree measure I can rotate it. And we already found this out, but we can do 360 divided by that order. 60 degrees is the magnitude. So I'm just putting names to these numbers now. All right, what about B? Does it have rotational symmetry at all before we discuss anything else? Come on, you can do it. Come on. You got it. Come on, dig deep. You got it. Get after. Come on. Okay, good stop. Pushed it too hard. What do we think? Rotational symmetry for B? Remember, rotational, 180 or less. Can you turn your paper 180 degrees or less and get this same right triangle back? Anybody? Me neither. So no rotational symmetry. Oh, can we get an update? All right. What about C, rotational symmetry? Can you turn it 180 or less? Yes, you can. All right. So now, how many times can you turn it and get that flag figure back from 0 to 360? How many times can I turn it? And I think this is going to help some of you guys out now seeing this visually. Here you go. Okay, everyone ready? Once, and back to the beginning. So I can do it twice. So the order I'm going to say is 2. Meaning, what's the magnitude then? What's the smallest degree measure I can rotate? I'm not giving up. Back in business. Never mind. Magnitude? I don't give up, as you can see. Magnitude would have been 180 degrees. Okay. Woo! Everyone all right with the symmetry? Now comes down to, yes, you can reflect over a line, but can you reflect over a point? I'll give you a second. Go ahead and get triangle art down. Okay, so reflect through a point. Guys, it is still a reflection. The distance is not going to change. Wherever A prime is, it's going to be the same distance from 4,1 as A is right now. Same thing with T and R. It's going to be easy for you guys to do A and R. How far is A from 4,1? 2 units. So you go 2 units in the other direction, and we end up at A prime. So again, 2 units away, 2 units in the other direction. There's A prime. I can do the same thing for R. How far is R away from 4,1? Should be how many units? 4 units. So I go 4 units in the other direction and get to R prime. Now what about T? And don't do this. Don't go, oh, well, T is only so many units from A, so I'll go that many units that way. All right, what if that doesn't happen, where you get a diagram where there's a horizontal and a vertical line, and you're stuck? How can I find, given T, reflect it through 4,1 without using anything from A and R? What do you got there, Matty Ice? So basically, what are you doing there? Slope. Slope's not going to change. All right, so how many do I go down and over there, Matt, since it's your idea here? So left 4, down 2, and guess what I'm going to do from this point? Left 4, down 2. Okay, so you can use the slope. All right, use the slope between the point of reflection and your pre-image. And just let me know what those coordinates are now. Matt, call a number for me. You just answered the last question. 10. What's R prime?
R is 0, -1. Or no, 0, 1. A prime is 4, -1. And T prime is 3.
Are we okay on reflecting through a point? Because I know I should have had a different example because it's easy just to count horizontally or vertically. I needed to make you guys use slope to find another point. And then final one is finding the actual point I reflected over. All right, so go ahead, graph ABC and A prime, B prime, C prime. Which point did I not line, which point did I reflect through? Probably pretty easy for many of you. You just see A and A prime, will just go right in between, and there it is. Or you can do that for B and B prime, go right in between. But what if all the points are like C and C prime on the homework? And you just can't go, oh, I'll go right in the middle. How are you going to figure out if all my points are like C and C prime, what point I must have reflected over? Got an idea, Saad? Okay, hold on to that one because I wanted to reveal that, but thanks for just blowing my spot up. Okay, let me go back to Matt's. What did you use, Matt, before to get to the image? Slope. So can anybody, here you go, I'm going to need somebody's help here. Frank, I'm going to need a number. 6. How many do I go over and down to get from C to C prime? So left 9? Is that what it is? Well, you're going from 5 to -3. Eight and down. Down 4. What could you do to that slope right here to get from C to C prime to find what's halfway in between? Do what to each? Cut it in half. So instead of going left 8, go left 4. Instead of going down 2, we could go down 4, go down 2. Okay? And yes, I don't know if anybody heard what Saad said, but if you find the point of reflection, let me just connect C and C prime. That's awful. Be professional. If I connect C and C prime, what's Saad? Go ahead, tell everyone, what is the point of reflection? It's the what? It's the midpoint of the line segment. So if you wanted to find the midpoint instead, the midpoint will be your point of reflection, which is what here? 1, 2? Okay, so keep that in the back of your mind that the point of reflection is the midpoint. All right, it's the midpoint of pre-image and image points. Okay. Half of it's coming from your textbook tonight. The other half is coming from your packet. Okay, so if you'd like to get going, feel free. Got plenty of time.